talk a little bit about technical recruiting and specifically the technologies that TalentBin does a really good job with. We understand that a lot of this technology stuff is pretty new for a lot of folks, and so it's important for us to help you kind of walk through some of the technology that TalentBin is really helpful in recruiting software engineers for. So that's going to be the purpose of this conversation today, is to walk through some of the front end, back end, data store, web server, and operating system, both open source, in here, and kind of Microsoft stack, in addition to mobile and big data stuff that TalentBin works with. So that's the goal today. So first, let's talk about front end. Essentially, the front end technologies are what the user ends up interacting with, typically in their browser, or potentially on a mobile application that's dynamic, but generally speaking, it's what a user is interfacing with. And there's kind of like two major buckets there. There's kind of static front end stuff like CSS and HTML, right? And then there's kind of what's known as like rich front end technologies, right? Rich client technologies, things like HTML5, JavaScript, Flash, and ActionScript. And so all of these things together kind of sum up into what's known as like Ajax, for instance. And so examples of this would be like a static layout of CSS and HTML. Those would be kind of just like web pages that you interact with, like on the NewYorkTimes.com or something like that. Whereas kind of richer front end technologies would be things like HTML5 is something you probably interact with if you ever use Gmail and you drag a file into your Gmail message, and it, lo and behold, it uploads through the browser as an attachment. That's HTML5. JavaScript is used for kind of animations and is the sort of things when you use like Gmail and you go to send a message or open a message and the page doesn't have to reload, but instead it just automatically happens. That's done with JavaScript. And there's other libraries associated with JavaScript and JavaScript frameworks like jQuery or Scriptaculous or what have you, but all of those are based on JavaScript. And then Flash is a technology that if you ever watch a video on YouTube or if you ever played a a Facebook game like Farmville or any of those are typically done in Flash, and it's a technology that's done that's developed by Adobe. And so again, all of these are kind of front-end technologies that generally speaking you interact with in a browser. Microsoft, as we'll kind of talk about, typically they have their own integrated stack, so to speak, and you'll kind of see this continuing here throughout this conversation, throughout this class. But their front end, historically, their front end technology was one called Silverlight. Okay, so those are front end technologies there. And so just to kind of make it kind of crystalline here, an example of like what the front end would be is like, so if you were using Karma, for instance, or Salesforce.com in your browser, and you were looking at the information that was being displayed on the page, that would be laid out with HTML, for instance, right? And when you go and commit something, when you go and enter an activity, you would be maybe some sort of JavaScript action would be cataloging that off before it was sent to the servers, to the back end, right? So that's kind of one way to think about that. So speaking of the back end, let's go ahead and talk about that. Back end, and so actually really quickly, front end technologies, oftentimes you can think of there are front end engineers who primarily spend their time working on these things. And so those, if you were looking for a front end engineer, rather than looking for the title front end engineer, if you found somebody who works in HTML5 or JavaScript or Flash or what have you, you automatically know that you have a front end engineer on your hands. Similarly, backend. The backend is the general term for what is used, the languages and the code that runs on servers that service the information, that service the front end, right? And so those kind of break into two different types of main languages. Main language types, you have compiled languages, and then you have scripting languages, right? And so compiled languages are the sort of things that you would learn in a computer science program. So anyone who's taking computer science in college would probably have taken Java, right, or a C++ class, for instance. And so, compiled languages have benefits. They also have pros. They also have cons. Pros of these compiled languages like Java and Scala and C and C++ would be that they have a tendency to be higher performance, right? Because they are compiled before they are run. They run closer to the to the processor, so to speak. And the downside with them is that they have a tendency to be harder to code in. What I mean by that is they have kind of more overhead associated with kind of the activities that the engineers have to engage in. And so, rather than kind of just like, picking up Java or picking up C++ and just like hacking together something really quickly, it takes more doing, right? So there's benefits and there's also downsides. And so typically what you end up seeing is because of that, because of the performance component, you end up seeing things like e-commerce and finance and things like that, high scale transactions, et cetera, end up being written in things like Java or C++ or what have you, right? So for instance, like Salesforce.com is written in Java for the most part. eBay is written in C++ for the most part. And then also these languages have frameworks associated with them, like Java. Java has Spring is a really popular framework for Java. J2EE is another one. Scala has Lift. C++ has TreeFrog, etc. So that's compiled languages. And then on the the scripting side, these are things that you might be more familiar with when you hear people talking about modern web applications and kind of social applications and things like that. And those would be languages like Python, Ruby, PHP, and Perl, right? And so again, the way that you would have, there are upsides and there are downsides associated with scripting languages as well. Typically, one of the upsides associated with scripting languages is they have a tendency to be more human readable and kind of easier to pick up, if you will. So when you're looking at a Ruby program, it's easier for a human to kind of read it and understand what's going on there, because it doesn't have as much of the formality of the compiled languages like Java or C or C++. There's less overhead associated with things. So that can be a good thing insofar as you can quickly prototype something together, right, or put together an application. It can be a downside insofar as if you don't do things correctly, it won't tell you. There is no compiler, right? It does not compile before it runs. And so if you mess something up in Java or C++ or what have you, when you go and put it through the compiler will yell at you and say, hey, you did this wrong, right? You don't have that on the scripting language side. And so, you can get yourself in trouble if you aren't paying attention. So usually, scripting languages are more flexible. You can be more loosey-goosey with them. And you definitely have, you have large-scale sites that are written in them, but typically what you'll end up seeing is you don't see a lot of like very high-scale applications written in these languages. Like the best example would be Facebook is written in PHP, but Facebook has had to do a lot of activities in order to get PHP to the point where it can support the activities that are on Facebook. Other examples would be Yelp is a Python shop, for instance. Twitter is famous for having been a Ruby shop, right? But then having to ultimately rewrite a lot of the service in Java. And so the things, if you were recruiting for, if you're recruiting for a early stage startup or a company that is trying to pull together kind of web applications quickly that don't necessarily require a lot of scale, you would see back-end engineers being recruited for with these scripting languages. And again, these guys also have frameworks as well. Ruby probably is one of the more famous ones. Its most popular framework is Rails. So you hear of Ruby on Rails, but there's also other Ruby frameworks too, like Sinatra is another one. PHP has Zend and CodeIgniter. Python has Django, Pylons, PyPy, so on and so forth, right? So again, what you would see is, examples here would be, you would see kind of like social applications and kind of like modern, modern applications like an Airbnb or an Eventbrite or something like that would typically be written in one of these scripting languages. here. And then on the Microsoft side, Microsoft has an implementation of a compiled language that essentially is, more or less an analog to Java, which is known as C#, in a collection of technologies based on C#, also known as .NET and ASP. Okay, moving on. Let's talk about data stores. Actually, really quickly, the most important thing about backend technologies is the concept that this is where the business logic resides in an application for the most part. Most of the time, the business logic resides on the back end and executes on the server side. Okay, and so the idea there would be that, again, a person, like, let's use Karma as an example again, right? We go and we exit, like, we're looking at something in the user interface of Karma in Internet Explorer in the front end, and we enter some information in there. That gets pushed to across the wire to the back end, running on the servers, right, where Siebel, which is the application that Karma is. I don't know if Siebel's written it's probably in Java, is running, right? And then some sort of activities happen, like, oh, okay, the business logic says that if I go and commit this, then these 10 things are going to happen. That's business logic, and that is typically run in the back end. Similarly, that business logic takes data and stores it and also retrieves data in order to present it and manipulate it. And so when you think about, and that's what data stores are for, right? And so when you think about data stores, you primarily have like two different types. You've got SQL and NoSQL data stores. SQL stands for Structured Query Language, and it's kind of the most typical there. A great example of that would be Oracle kind of rose to power on selling very expensive Oracle databases that were SQL databases. And the idea behind SQL data stores is that you can store data in a structured format such that you can query that information in a very structured format, right? MySQL is an open source implementation of SQL and has become very popular in the open source community with, as a data store of choice. There are other variants like Postgres or PostgreSQL that is, again, a SQL data store that is an open source implementation. So when you hear the LAMP stack, LAMP, that typically stands for Linux, Apache, MySQL, and PHP or Python or Lammer, right? And so MySQL is very popular there. On the NoSQL side, NoSQL, if you thought that SQL is structured query language, NoSQL you would assume would be unstructured data, and so that's actually the case. And what NoSQL is really good for is, whereas SQL is very good for being able to query information in a structured fashion and ask your data very specific questions, it has scaling limitations. So if you wanted to enter a few billion rows of data into MySQL, it might be pretty tough for you to do lookups, and they would be slower. There's an overhead associated with that. However, if you wanted to have a few billion rows of data in Cassandra or Redis or what have you, right? It would allow you to do much faster lookups, but you couldn't ask the data as flexible of questions. So if you wanted to have, for instance, a data store where you had a billion people, given ID numbers like 1, 2, 3, 4, 5, and next to each of those UIDs, you had their favorite color shirt or a set of favorite color shirts. But you knew the only thing you wanted to do was go and ask Cassandra, hey, user 5285, what are his favorite searches, right? NoSQL would be very useful for that. It would be instantaneous recall, more or less. And so so there's a trade-off there where what you couldn't do is you couldn't go and say, hey, actually, just kidding, instead of just giving you a user ID and you telling me what color shirt they have, what color shirt their favorite is, can you show me everyone in this who likes purple shirts? You would not be able to do that in NoSQL in an easy fashion. You would be able to do that in SQL in in a structured in an easy fashion. So those are kind of the trade-offs here. NoSQL is oftentimes associated with big data insofar as when you get into the millions and billions of kind of pieces of data, oftentimes you outstrip the ability of a structured query language data store to be able to help with those. And then the Microsoft version of this is, of course, Microsoft SQL Server. All right, so those are data stores. So next up, we've got some web servers. So let's talk about web servers. Essentially, when you think about that back end, right, that back end code where the business logic is executing, those applications run on a web server, right? So when your browser goes and goes to connect to the application that's written in Java, right, that's talking to a MySQL data store, that application is running on a web server, right? The most popular of which is Apache. This is an open source one. Tomcat is an open source one as well. And some of these web servers have association with certain languages. So like Mongrel, for instance, is associated with Ruby. So is Thin. Apache is kind of all-purpose. It's actually the most popular web server out there. And again, like the LAMP description of Linux, Apache, MySQL, and PHP, Apache is the A. Tomcat is an open source web server that's associated with, popularly with Java, and WebSphere is another very popular Java web server, right? And of course, Microsoft has its own implementation as well. Then let's talk about operating systems. Operating systems is what all of this information runs on, or sorry, what all these different applications run on. And so the operating system, much like on your machine, your personal computer, you might have Mac OS X, or you might have Windows. Those servers have operating systems as well. Linux, of course, is a very famous one. It's an open source implementation of the Unix style operating system. Solaris is another example of an implementation of Unix that is specific to Sun, right? But Linux is really the most popular when it comes to kind of like web applications and things like that. And then you have different flavors of Linux. You might have like Ubuntu or Red Hat or Fedora or what have you. Ubuntu is actually one of the most popular on that front. And so again, if we're back in the day, if we were a bank, in the late 90s, we might have servers running, we might have Sun servers running Solaris Unix, right, running WebSphere application servers, running applications that have been written in Java talking to an Oracle data store, doing financial transactions or what have you. Nowadays, the more common case would be you would have a server running on Amazon Web Services that it has a Linux operating system, probably Ubuntu, running an Apache web server that's running an application written in PHP, for instance, right? Talking to a MySQL data store, and then maybe for some use cases, talking to Cassandra or Redis or what have you for NoSQL uses, or maybe using memcached for caching, right? So that's kind of like a more modern web stack there. And of course, on the operating system side for Windows, Windows is Windows's favorite operating system. And so with Microsoft, you have this kind of like vertically integrated stack here where you have, Windows running IIS. IIS is Windows Web Application Server. MS SQL Server is the Microsoft data store, and then C#.NET is the application language there. So that's kind of this stack, and so there's kind of a metaphor of like this is the front and this is the back, and so you hear about back-end engineers. Typically, what a back-end engineer is spending his time or her time writing writing business logic applications with these various languages and talking to these data stores. You might have somebody who spends most of their time interacting with data stores, and that could be like a database architect, which is a little bit different than a database administrator. And then you might also have someone who's known as like a full stack engineer, right? They're comfortable working on stuff in the front end, working on JavaScript and HTML stuff. They're comfortable working on stuff in the back end. They might even like be comfortable with Java and comfortable with like Python. And so this would just be like a simply this is going to be a more senior engineer who's more of a generalist. So that's kind of like the stack there. And then, other things to think about too is on the mobile front. Mobile's obviously a really big thing when you're developing apps and things like that. There's really kind of just two big players there. There's on iOS. iOS applications are written in Objective-C, and now Apple just announced Swift, right? So if you're doing iOS apps, it's primarily going to be Objective-C and Swift, right? And the same is actually true for Mac apps too, like Mac, machine ones. On the Android side, the language is Android, and it's actually a descendant of Java. So, typically when recruiters are looking for Android engineers, they'll look for people who are doing Android stuff, but also a Java person can kind of do in a pinch. And then one of the last things to talk about here is like big data. And so it's kind of related to the NoSQL stuff we were talking about before, but the idea behind big data is like if you're consuming and making sense of massive data sets in order to derive insights from it. That's kind of the general idea behind like big data is like, data mining and things like that. And so what you would end up doing there is using tools to store massive amounts of information, typically in a NoSQL solution or a NoSQL tool, but it doesn't necessarily have to be that. And then running queries against it or running processes against it in order to derive information. So in our example of, the t-shirts or the shirts, right, if we had 1 billion folks with like their shirt information, but it was unstructured, what we might do is we might use Hadoop, right, to interrogate in a batch process all of those different files that have that information of individuals and their shirts, and then extract that information over time and then return it back to me. It's not the same as doing a quick lookup on structured data because again, it's not structured, right? Because having billions and billions and billions of rows of data in a structured query language database would be very hard on it, right? But this is, instead, what I can do is I can do a offline process, in Hadoop in order to consume that information. Then there's a bunch of management tools associated with, to make my usage of Hadoop or HBase or what have you better. And so those are like Hive, Pig, Zookeeper, et cetera, right? So that's kind of a crash course there. You should, you can watch this a couple times and refer back to it when you're taking your test. But generally speaking, and also refer back to this, this cheat sheet itself. It's present on Inside Worldwide. But, generally speaking, these are a lot of the technologies that people are recruiting for, and TalentBin is really helpful for recruiting for all of these.